Okay, so welcome to lesson 2.2. Read the problem of the day, pause the video and answer it. All right, so our lesson today, 2.2, find slope and rate of change. All right, so key concept, once again, this should still be an Algebra 1 review. We talk about the slope of the line. In words, the slope m of a non-vertical line is the ratio of vertical change of the rise to horizontal change of the run. Algebra, and you guys are pretty good with this. The slope m equals y2 minus y1 over x2 minus x1, or the rise over run. And then here's the graphical representation of it as well. And what we're going to be doing in example 1 is we're going to take a look at actually finding the slope of the line. What I want to do, I actually have to add these for you here. So let's draw a point. You could pick any point you want, but I'm going to label this as 4, 4. And I'm going to use the point over here, which is -2, -5. All right. So we're going to use these 2 points to find the slope of the line. And I'll write them over here because my writing is still sort of terrible. So I'm going to use the points 4, 4, and -2, -5. Now, honestly, it doesn't matter. Actually, I could have told you to pick any points you want. I looked for points that were nice and right on the line. There's a point here that you could have picked, or here. But let's just draw those two, and we're going to use our slope formula. So m equals, I have y2 minus y1, so -5 minus 4. And just in case you need a little reminder, this is x, whatever you write first is sub 1. So x1, y1, hopefully you remember this, but I will talk about it. This is x2 for the slope formula, and y2, just in case you need it. So I'm taking my x's, or excuse me, my y's. So -5 minus 4, and then I'll do -2 minus 4. So let's see here. And we'll simplify. You should get -9, right, over -6. And we could further simplify that too. Negative divided by negative is a positive, so we get 3 over 2. Three halves is my answer. Okay. So make sure you simplify, get rid of the negatives and whatnot. Example 2, we're going to do the slope again of these 2 points. So here's the graphical representation. Here's one where I just give you the actual points. So set it up here. Pause the video and try it yourself first. We want y2 minus y1 over x2 minus x1. All right. And then check your work when you simplify. You should get 3/10. Okay, so check your work. Careful your double signs. All right, so now, classification of lines by slope. The slope of a line indicates whether the line rises from left to right, falls from left to right, is horizontal or vertical. So positive slope, I think of how we read. We read from left to right, all right? So it rises from left to right, negative falls from left to right. 0 is a horizontal line, undefined is vertical. Remember, I think of undefined as, how I remember it's vertical is if you take a look at, I don't know, I would think of a vertical line as a cliff. Fall off a cliff, you take your car. Can you really drive your car along the cliff? No, it's going to fall off into the air, right? Zero slope is flat land. You can drive your car along zero slope. So that's usually how I remember the difference between them. All right, so we're going to, in example 3, tell which line is steeper and whether each line rises, falls, horizontal, or vertical. Okay. So I'll start here with L line 1. I usually use little subscript here. So L1, I should get negative 2 minus 1 over 3 minus 3. Which equals negative 3 over 0. And if we know negative 3 over 0, that is actually, we cannot divide by 0, right? You're not allowed to divide by 0, it just doesn't work, it's undefined. If you're doing a calculator, if you type in negative 3 over 0, you're just going to get an error message. So this is undefined slash vertical. I'm running out of room here. All right, and let's do L2. I'll write that one over here, give myself a little more room. I do a little subscript so I know which line I'm evaluating. Yeah, 5 minus 4 over 2 minus negative 2. All right. Actually, let me space that out a little better since I spaced that one. And what we get is actually what, 1/4. All right. And 1/4 is a positive 1/4, right? Positive 1 over 4. So no matter how much it moves, it rises still because it's positive slope. I'll just type that and fix this. So it rises or because it's a positive slope. Now the other thing we have to figure out which one's steeper. All right. So if I graph 1/4, I go up 1, right 4, up 1, right 4. So it's not really too steep, right? But if I look at the undefined one, well, that's going to be a vertical cliff. So the one that's steeper is this one. So make a note here, steeper. So steeper is the bigger the number, like the absolute value of it. So if it's bigger than 1, it's going to be steeper, like 2 is steeper, 3, 4, 5, and so on. But if you get something less than 1, like a 1/4 or a fraction or a decimal, 1/4, 1/2, something along those lines between 0 and 1 or 0 and negative 1, that's going to be not as steep. Okay? So next key concept. With two lines, we talked about their similarities here, and now we're going to talk about what makes something parallel or perpendicular. So consider two different non-vertical lines, L1 and L2, with slopes M1 and M2. Parallel lines. Lines are parallel if and only if they're the same slope. So if M1 equals M2, they are exactly parallel as the picture shows. Perpendicular, the lines are perpendicular if and only if their slopes are negative reciprocals of each other. That's a very, very important term, negative reciprocals. We talked about that in the pretest. Here's another representation for it. M1 equals negative 1 over M2. A shortcut to test also, another way to test if they're negative reciprocals is if you multiply them together, you get negative 1. And you know perpendicular makes a nice little right angle there. Okay, so example 4. All right, tell whether the lines are parallel, perpendicular, or neither. Line 2, 2 points. So I'm going to start off by typing the slope for M1. I usually write M sub 1. And remember, it's y2 minus y1 over x2 minus x1. All right. I'm just going to write the next part here. The denominator will be 0 minus a negative 2. And when I calculate them, check your work, you get negative 6 over 2, which will simplify to negative 3. Okay? So that's M1. Now let's do the same thing for M2. So M sub 2 get 10 minus 1 over negative 3 minus 0. Which equals 9 over negative 3. And finally, I will get negative 3 for my answer. So if we take a look here, both slopes are negative 3, right? So if I found out that slopes are the same, we know that they'll never intersect, so hence they are parallel as our answer. All right. Same with line 2, and or part B, line 1, line 2. M sub 1 equals negative 3 minus 3. Over negative 2 minus negative 5. Which equals negative 6 over 3. Negative 6 divided by 3 is negative 2. So that's slope of the first line. Same thing with M2. M sub 2, or line 2. We get negative 5 minus 11 over negative 4 minus 4. Which equals negative 16 over negative 8. And negative 16 divided by negative 8 is a positive 2. So let's take a look. My slope for m1 is negative 2. My slope for m2 is 2. Well, we know they can't be parallel. Yeah, they're the same number, but the signs are wrong. And it can't be perpendicular either because perpendicular is negative reciprocal. Yeah, one's positive, one's negative, but they are not reciprocals of each other. So in this case, their answer is neither. Okay? Now, the last one's a word problem here we're going to read through, showing you how to use slope or rate of change as a word problem. And it's a forestry problem. It says, use the diagram which illustrates the growth of a giant sequoia to find the average rate of change in the diameter of the sequoia over time. Then predict the sequoia's diameter in 2065. Okay, well, I don't know if you've ever seen the giant sequoia trees. That's over in California in a national park. And I went there a couple years ago. It's beautiful. I figured I'd add a little. If you look off to the right little corner, that's me and my husband actually in front of the General Sherman, which is the largest sequoia tree. And it's actually, if you haven't been there, if you get a chance to go, or if you even look it up online and watch videos, it's amazing. These trees grow for thousands and thousands of years. And what's interesting, the type of tree they are, the sequoia, they never die. Very rarely are they killed off. It was interesting to see, even if there's like a fire, maybe part of the tree is damaged, but it still continues to grow. So maybe anymore it won't grow wider, but it'll still grow taller. It's just so neat to see for how old they are, how big they are. And I figured I'd put that little picture up here in the corner to show you how small we look compared to the trees. So it is actually pretty neat, and it's a real life application, right? We want to predict the growth of something a lot farther from now, a ways off, I guess I should say. So here we have the diameter that they measured in 1965. It was 137 inches. And then they measured again in 2005 at 141 inches. So it's a constant rate of change how these trees grow, give or take a little bit, but it's a rate of change. Every year they grow this much. We want to be able to predict, all right, well, what about in 2065? What would the tree look like then? So what we have to do first is I'm actually going to take these numbers and write them as an ordered pair. And we'll talk more about this with word problems the next day, okay? Because you'll see in the packet that one of the assignments deals with word problems. So what I'm going to say is time is always x or independent. So 1965 is my x coordinate, and 137, is my y coordinate. All right, and once again, anytime you do a word problem, the independent variable is time. Time always goes at the same rate, doesn't matter what happens. So how much the tree grows is the dependent variable, or the y coordinate. That's a good rule of thumb to know for word problems. All right, well, let's write the other one as an ordered pair as well, 2005, 141. So we're going to find the rate of change, the slope, all right, or rate of change. A lot of times when it's a word problem talking about something in specifics, call it rate of change. So solve your problem, all right. I'm going to get 141 minus 137. And over 2005 minus 1965. And you guys could do the math at this point. It shouldn't be that difficult. If you calculate it, it simplifies in the end to 1/10. All right. And that's the growth in 1 year. And that's in inches. So it actually grows 1/10 of an inch per year. And that's actually pretty amazing to think about because 1/10 of an inch is so tiny and so minuscule. But these trees are so old. That's why they are so big, because of how their age. All right, so we know that it grows 1/10 of an inch in 1 year. All right. So the next part we're going to take a look at is figuring out where we go from here. All right, if you subtract 2065 minus 2005, okay, so we want to subtract that time because I want to see how many more years from the last measurement we took has elapsed. So if we subtract, we get 60 years. All right, so 60 years later we're looking at. Okay, so we'll take 60 times 1/10. Because if it grows 1/10 of an inch a year, during 60 years, I want to see how many actual inches that is. So 60 times 1/10, and we actually get 6 inches. So that's sort of amazing as well, right? Because it only grows 6 inches in 60 years. That's pretty crazy to think about. So the last thing we got to do is, all right, what was the last measurement in 2005? Because we're looking at past 2005, 60 years. Okay, so we had 141 inches plus 6. All right, so it grows 6 more inches. It'll be 147 inches in 2065. Right? So here's a way we can actually do a word problem with rate of change here. I'll box my answers as best as I can here. All right. So that's it for today. Here's your homework. Make sure you pause the video, copy them down, and solve them. The problem of the day, want to find the slope. Tell me about what happens with those lines. And finally, parallel, perpendicular, neither.